Welcome to the lecture on applications of LaTeX. I am Tapashika Das, and today in this session we will provide an in-depth exploration of various applications of LaTeX. We will discuss various practical applications of LaTeX, from creating professional resumes and structured question papers to generating precise mathematical plots. Here is an outline of the topics we will cover today. The lecture will begin with resume and CV writing, enabling learners to design visually appealing and structured professional documents. After that, we will discuss question paper preparation, showcasing techniques to create well-formatted assessment materials suitable for academic settings. Finally, at the end, the applications of TICZ and PG plots for function plotting will be introduced to equip learners with the skills to visualize mathematical functions and data effectively. Now let me come to the introduction part. LaTeX is not just a typesetting tool. It is a powerful document preparation system and markup language that can transform the way you create content. In our previous lectures, we have explored how LaTeX can be leveraged to create academic papers, reports, presentations, and even books. Let us quickly revisit some of the most popular applications of LaTeX. Number 1. For creating academic and research papers. If you are writing papers for scientific journals or conferences, LaTeX is ideal. It allows you to structure your work with precise control over sections, subsections, footnotes, citations, and bibliographies. Next is writing articles and books. We have already learned to use LaTeX for writing manuscripts, articles, and books. One of the key features of LaTeX is its ability to manage long documents. LaTeX automatically generates a table of contents, indexes, list of figures, and tables, making the process smoother as your document grows. Next, creating presentations. Using Beamer, we can now create slides with bullet points, text, and images in a consistent style. We can also go a step further with overlays, transitions, and custom themes, all while ensuring that our presentation looks polished. Next is creating reports and business documents. Beyond academia, LaTeX is used in creating reports and business documents. Companies and professionals rely on LaTeX to write high-quality reports that may require custom layout, graphs, and tables. Next is for technical documentations. For technical documentation, LaTeX provides an ideal platform. LaTeX supports for multiple programming languages, also allows you to incorporate code snippets with syntax highlighting. After that, LaTeX can be used for personal projects and non-academic uses. Though LaTeX is predominantly used for academic and professional purposes, it can also be a valuable tool for personal projects. If you enjoy writing, LaTeX can be used to produce stylish resumes, personal portfolios, and even creative works like poetry and short stories. Now we are going to discuss in detail how LaTeX can be used for creating resumes and CVs. Resumes and CVs summarize an individual's professional and educational background. Using LaTeX, these documents can be created with a polished and professional look. Classes like Modern CV and Resume CV offer pre-designed templates for resumes and CVs. It also includes sections for education, work experience, skills, and contact details. LaTeX ensures clean layout with consistent alignment, font, and spacing, enhancing readability. It also allows easy customization and rearrangement of sections, making organization flexible. Let us look at two approaches, a simple template and a powerful modern CV class. For a simple resume, we can use the article class. We can organize content into sections like education, experience, and skills. Here is an example of basic structure, and here we see the output. In this template, the name of the person is included using the /def/name then field. This is being included in the article class. Geometry package can also be used for customizing the layout with specific margin. After name, email, phone, and social media link can also be included using the command /name/email/social media link, etc. The main part of the resume begins with the /begin document environment. The page style empty option can be used to remove the page number. Within centering environment, we can display the name and other personal details at the top center position of the page. Following this, the other details can be included using /section/section star commands as shown here. Section number will not appear when we use the /section star. Here education, experience, skills, projects are some of the sections. Each section is organized for easy readability, making the resume both professional and concise. The modern CV class is a popular choice for creating professional resumes. It provides predefined templates with options for including your photo, contact information, and well-organized sections. The modern CV class is a highly customizable and professional LaTeX document class specifically designed for creating resumes and CVs. It offers a clean and modern layout with various predefined styles and color themes, making it easy to produce visually appealing documents. With the support of the powerful formatting capabilities of LaTeX, modern CV not only ensures alignment, font style, and sectioning, but also allows for personal customizations of headers, footers, and content layout. This class supports detailed sections like education, experience, skills, and projects, with options to include links, photos, and social media profiles. It is an ideal choice for creating polished and well-organized resumes that adhere to professional standards. Let us provide a simple template of modern CV. The output generated by the template is as follows. This template uses the modern CV class to create a professional and structured CV. It begins with the document class within third bracket 10 point, A4 paper within second bracket modern CV, specifying the font size and the paper dimensions, and employs modern CV style banking for layout style. For the color theme, the command modern CV blue is used. Page margins are adjusted using the command line /use package scale equal to 0.8 within second bracket geometry. This is the command for setting the page margin. Personal details such as the name, email, phone, and social links are added with /name, /email, /phone and /social respectively. The command /social platform next URL facilitates the addition of social media links such as LinkedIn or GitHub. Major sections like education, experience, skills, and projects are defined using /section, while entries are formatted with /CV entry, which includes fields for titles, dates, organizations, locations, and descriptions. Bullet-pointed list or tasks or skills are created with /begin itemize and an itemize command. Projects are highlighted with /CV item, allowing concise descriptions. Let us take a moment to assess your understanding with a few couple of multiple choice questions covering these sections. Number 1. Which LaTeX class is used in the provided template for creating CVs? Option A, article. Option B, modern CV. Option C, resume. And option D, CV doc. The correct answer is option B, that is modern CV. Next question. What does the modern CV style command specify? Option A, font size. Option B, page margins. Option C, layout style. And option D, color theme. The correct answer is option C, layout style. Next question, which command is used to add social media links in the CV? Option A, contact. Option B, email. Option C, social platform next URL. And option D, links. The correct answer is option C, /social platform then URL. Next question, how can a professional photograph be included in a CV? Option A, include photo. Option B, photo. Option C, /image. And option D, /pic. The correct answer is option B, that is /photo. Next, we will explore how to use LaTeX for preparing question papers. LaTeX is a powerful tool for creating clear and professional question papers. LaTeX ensures a consistent and neat layout for questions, sections, and marks. Teachers and educators can also include mathematical equations, diagrams, and tables without affecting the layout. With packages like exam and exits, teachers or educators can organize questions into sections, mark distribution, and assign points. The exam class is specifically designed for this purpose. Next, the key features of the exam document class. The exam class includes features like automatic numbering, flexible formatting for different question types, and even the generation of an answer key. These features save time and maintain consistency in the question paper. The command /question is used for defining individual questions, which automatically formats them with proper numbering. The /multi-question command allows grouping of multiple related questions under a single header, ensuring clarity and organization. The /marking command facilitates the assignment of marks to the questions. The /points command provides a more detailed breakdown for specific sections or subsections. The /section and /subsection commands are available to structure the exam into logical sections. /true/false and /fill-in-the-blanks support specific question types. With these commands, the exam class specifies the creation of exams with consistent formatting and organization. In this segment, we'll explore how to structure and format a question paper using LaTeX powerful exam package. Let's go through the provided code step by step. For document setup, this code is written. This section initializes the document using the exam class, which is specifically designed for formatting question papers. We also include the graphics package here for handling images and geometry to set up the page margins. This section is for header with institution details. Here we create a structured header that includes the institution's logo, name, department and exam details using mini page. The /include graphics command inserts a logo while the /begin center environment centers the text. For exam duration and instructions, this code is written. This section specifies the duration, semester and maximum marks using /uline for underlined text. It also provides exam instructions using /BF series to make them bold. For formatting the question, this code is written. This section starts with the question environment, which manages the numbering of questions. The /question command defines a new question and /begin within second bracket parts structures sub-questions with assigned marks in bracket. For additional question types, this code is written. This section follows the same structure for the exam class for handling different question types and weightage. Finally, the exam paper concludes with a formal closing statement formatted using the BF series for emphasis. The exam document class in LaTeX provides an efficient way to format and organize question papers with structured sections, numbered questions, and custom formatting. This ensures a professional and consistent appearance, making it ideal for academic assessment. It is also possible to prepare a simple question paper using article class. We have also discussed creating presentations with Beamers in previous lecture. Beamer offers a variety of themes, color schemes, and options for adding animation and overlays. Let us discuss applications of TickJet. The TickJet package is a versatile tool in LaTeX that allows users to create high-quality graphics within a document. This can be used for precise function plots, drawing complex mathematical functions, geometric shapes, and data visualization with ease and precision. This capability makes it an essential tool for creating professional documents that integrate text and visuals. The use of TickJet for function plotting involves understanding its basic structure and customization options to achieve the desired output. Using TickJet for plotting functions provides several advantages. First, it offers precise control over the appearance of plots, including axis levels, grid lines, and colors, ensuring that the graphics align with the document's formatting. Second, TickJet integrates seamlessly with LaTeX, enabling the inclusion of equations, annotations, and legends directly within the plot. This integration allows for consistent formatting and ease of editing. Additionally, TickJet supports overlaying multiple plots or combining graphics with textual elements, offering flexibility and creativity in visualizations. With TickJet, you can define and plot mathematical functions effortlessly. You can also customize the line styles, colors, and labels to match your needs. The basic structure of a TickJet plot involves three main components. The first component is the axis setup, where axes are defined along with grid lines, labels, and ticks to provide context and structure for the plot. Next, the function to be plotted is specified using the plot command, allowing precise representation of mathematical functions or data. And lastly, customizations such as colors, line style, and labels can be applied to enhance the visual appeal and clarity of the plot, ensuring it effectively conveys the intended information. Now let us learn how to plot mathematical functions. Here is an example of a simple function plot using TickJet to visualize fx equal to x squared. The provided TickJet code demonstrates the usage of various commands to create a simple plot of the function fx equal to x squared. The begin TickJet picture environment initializes the graphics. The draw command is used repeatedly to construct different components of the plot. The first instance, /draw within angular bracket, creates the horizontal axis with an arrow pointing right and labels it as x, while the second instance does the same for the vertical axis labeled fx. The command draw helplines creates a grid within the specified range, helping to visualize the graph more clearly. The following command plots the function fx equal to x squared within the domain of -2 to 2 using 50 sample points for smoothness. The plot command inside that draws the curve, and the node right option adds a label to the curve indicating the equation fx equal to x squared. Together, these commands create a precise and visually clear graph of the function. The resulting output is shown here. Here is the code for plotting mathematical functions in LaTeX using TickJet. In this segment, we'll explore how to visualize mathematical functions with precise and customizable plots. Let us begin by understanding the core components of function plotting using TickJet. Let us take a closer look at the LaTeX code provided for plotting the function fx equal to x squared. The code starts with the standard document class and necessary package inclusions. Here we use the article document class and we include the TickJet package, which is essential for creating graphics along with the AMS Maths package for mathematical expressions. Next, the document environment begins, and we set up a title for our function plot using text formatting commands. This command ensures that the titles of the plot is centered and clearly visible above the graph. Now for drawing the axis, let us examine the commands responsible for drawing the x-axis and y-axis. Here are the commands. The draw command is used to create the x-axis and y-axis with arrows. The node right and the node above commands add labels to this axis, ensuring clarity in the plot. Now for creating a grid for the plot, a grid is added to the background using the following command. This command generates a help grid in the background between the specified coordinate limits. It helps in the better visualization of the function value at different points. Now let's see how the function f(x) equal to x square is actually plotted. Here are the commands. Thick command ensures the function curve and is drawn with a thicker line for better visibility. Domain equal to -2:2, it defines the range of x values from -2 to +2. Samples equal to 50, the numbers of points used to smooth the curve. More points means a smoother graph. This plot command defines the function f(x) equal to x square, which is evaluated for all x values in the given range. This node right command adds a label next to the plotted curve. With these commands, we generate a smooth, properly labeled parabolic curve representing f(x) equal to x square. TIGZ also supports plotting functions directly within LaTeX. Beyond simple polynomial functions, TIGZ also allows us to plot trigonometric functions like sine waves. Let us consider an example. In this code, we define axes similar to the previous example. The /draw domain equal to 0.6.28 command plots y equal to sine x and from 0 to 2 pi. The smooth keyword ensures a continuous curve. The blue option colors the sine wave in blue for better visibility. Finally, the node command places the label y equal to sine x near the curve. In addition to mathematical functions, TIGZ can handle data plotting. You can import data from external files and create visualizations like bar graphs and scatter plots. This is especially useful for presenting experimental data. Here we provide a code that uses the pgfplots package, a robust extension of TIGZ, to create a plot illustrating the variation of temperature with height in the troposphere. For data plotting, we will explore how to use the pgfplots package in LaTeX to create high-quality data visualization. The pgfplots package extends the capabilities of TIGZ and provides a powerful way to generate plots with customizable features. Let us go through the provided LaTeX code step by step. For document setup, The document class is set to article with a font size of 12 point. The PGF plot package is loaded, which allows us to create high quality plots. Next, initializing the TickJet picture. The /begin TickJet picture command starts the environment for drawing graphics. Next, for setting up the axis, the /begin axis command initializes the plot with various options. Title equal to variations of temperature in the troposphere assigns a title to the graph. X label and Y label defines the labels for the x-axis and y-axis. Xmin and Xmax set the range of the x-axis, and Ymin and Ymax do the same for the y-axis. Xtick and Ytick defines the position of tick marks on the respective axis. Legend position equal to northwest places the legend in the upper left corner. Y major grids equal to true enables grid lines for better readability. Grid style equal to dashed makes the grid lines dashed for a clearer distinction. Next, for plotting the data, the /addPlot command is used to plot the data points. The color equal to blue, marks equal to square. Options specify that the data points should be displayed as blue squares. The coordinates block list x, y pairs that defines the data points. Next, for adding a legend, the k command labels the plotted data. And for closing the environment, the AND axis and AND TickJet picture command close their respective environments, finalizing the graph. And here is the output. To summarize, we explored several applications of LaTeX, including resume writing, question paper preparation, and data visualization. Each of these tools enhances productivity and ensures high quality outputs. For resume and CV writing, we discuss how to design polished professional resumes using LaTeX, leveraging pre-designed templates with the modern CV class for a structured and visually appealing layout. For question paper preparation, we examine the exam document class and how it simplifies formatting question papers with automatic numbering, marks allocation, and structured sections for clarity and consistency. For function plotting with TickJet and PGF plots, here we explored the power of TickJet and PGF plots for creating precise mathematical functions, plot, and data visualization, adding clarity and impact to technical documents. With these tools and techniques, you now have the knowledge to efficiently create professional and well-structured documents using LaTeX. Let us take a moment to go over a few quick multiple choice questions related to the topic covered in this tutorial. First question, which command in the exam class is used to start a question? Option A /start question, option B /question, option C /create question, and option D /begin question. The correct answer is option B /question. Next question. How can you assign points to a part of a question in the exam class? Option A, slash part within third bracket points. Option B, slash points within third bracket part. Option C, slash assign points. And option D, slash score within third bracket part. The correct answer is option A, that is slash part within third bracket points. Next question. Which command in the exam class is used to organize questions into sections? Option A, slash section. Option B, slash subsections. Option C, slash start section. And option D, slash begin section. Correct answer is option A, slash section. Thank you for joining this session. If you have any questions or feedback, feel free to reach out. Thank you.